Starting up here. Here we go. Alright, 2.4 now in Trig. We are, I guess it's actually supposed to be 1.4, but it is on complex numbers. So let's take a look at complex numbers, shall we? So, complex numbers. You have a regular number, and then you have a number with an I. That I is imaginary. Okay, so this I here stands for an imaginary number. So you just have an I for an imaginary number. You have a real number plus an imaginary number, and you can have a real number minus an imaginary number as well. Okay. So I, what is I? What is an imaginary number? An imaginary number is the square root of -1. That's an imaginary number, and the reason why that's an imaginary number is because you cannot take the square root of a -1. You can't take the square root of a negative number, so that's what I stands for. So a plus bi when b does not equal 0, because if this was 0, then there wouldn't be an imaginary number anymore, because this would all cancel out, and all you'd have left is the real number. So just something there to keep in mind. So properties, just something for you to remember. Properties with I, with imaginary numbers, is that I is the square root of -1. I squared is equal to -1. The reason being is I squared is like saying I times I, and that's like saying the square root of -1 times the square root of -1. And if you remember, whenever you have the square roots, whatever's underneath, you can multiply them together. -1 times -1, is what you're basically supposed to do when you combine them together. But whatever's the same item underneath is what you end up with. So like square root of 2 and square root of 2 is 2. Square root of 3 times square root of 3 is 3. Well, square root of -1 times the square root of -1 is just -1. I to the third is -I, and the reason being is if I squared is -1 and an I is just one of those, then you're basically having a -I when you combine them together, right? Because right here, those two become a negative, right? That's a -1, and this right here becomes an I. So 1 -1 times I is a -I. And I to the fourth is positive because it's like saying square root of -1 times square root of -1. These become -1, and these become -1. What's -1 times -1? That's a positive 1.
Shampoo is better. I go on first.
Addition and multiplication of complex numbers. So let's take a look here. All you're basically doing here is combining things that look alike, just like combining like terms. I got a 3 and a 2. 3 plus 2, it's 5. I got 4 i's and 5 i's. That means I have 9 i's. That's it. 5 plus 9i. It's what you've been doing your whole life. It's just you have to keep in mind this is an actual number. It's an imaginary number. Example 2. Multiplying is like foiling. It's all the same. 3 times 2 is 6. 3 times 5i is 15i. 4i times 2 is positive 8i. And 4i times 5i, 4 times 5 is 20. I times I is I squared. So you combine your like terms, and here's what you have. 6 plus 23i plus 20i squared. There's only one catch to all this, and the catch is very simple. That catch is the I squared. That's why we went over those properties, because now that we know what I squared actually stands for, we have to substitute what that is, and we know that I squared actually stands for -1. So I take that I square out and I put a -1 in there. So now I end up with a 6 plus 23i minus 20, and now I have another, the 6 and the -20 are like terms. So I end up with a -14 plus 23i, because you can always put the number out in front. So, example 3. This is just some crazy foiling and combining like terms. That's all it is. So 2 times 3 is 6. 2 times -6i is -12i. 4i times 3 is positive 12i. 4i times negative 6i is negative 24i squared. Then we have 8 times 2 is 16. 8 times 6i is positive 48i. Negative 4i times 2 is negative 8i. And negative 4i times 6i is negative 24i squared. So I just combine everything that's the same. Alright, I got a 6 and a 16. That's 22. Negative 12i and 12i, they cancel right out. 48i minus 8i is 40i, so that's why it's positive 40i. Negative 24, negative 24 is negative 48i squared. Just like the last problem, you got to remember that I squared is actually negative 1. So I'm going to take out that and put a negative 1 in there. Negative 1 times a negative 48 is positive 48. Then I combine the 22 and 48 together, and I get 70 plus 40i as my final answer. So with this problem here, might look a little confusing for you at first, but just combine things that share like amounts together, portions of it together. And here's what I mean. What I mean is we have x's and y's. We can't solve for both of them, but here's what I do know. This front part is supposed to be an 8, and this back part right here, they're also supposed to be equal. I know these back two parts are supposed to be equal because I have an I there and there, so I know that they're supposed to be the same. That means the front parts have to be the same. So basically I have two equations I can set up. 2x minus 4 equals 8, and then the other equation I have is a 9i equals 3y plus I. So this is something else to keep in mind. So to solve this, I add 4 to both sides to get a 2x equals 12. Divide by 2, and I end up with x equals 6. This equation now is 9i equals 3yi. Well, I can divide both sides because I'm trying to get y by itself. Divide them by an I, right? Because if I divide by an I on both sides, the i's are gone, leaving me with 9 equals 3y. And then from there, I can divide both sides by the 3, and I get y equals 3. And if you plug both those in, it'll be the same on both sides. Alright, so we'll try another example out just like that when we come back.